Hello everyone and welcome back to our YouTube channel, The Quality Analyst. If you are learning software testing, one topic that almost always appears in the interviews, real projects and daily testing work is the defect life cycle, which is also called as bug life cycle. Many beginners memorize defect statuses such as new, open, fixed, close, reopen, but they don't truly understand who changes the status, why it changes and what really happens in the real projects. So in today's session, we are going to understand the defect lifecycle step by step, exactly the way it happens in a real time projects using a practical example. And by the end of this video, you will be able to confidently explain this flow in the interviews as well as in the project discussions. So let's begin. So before we talk about the defect lifecycle, let's first understand what a defect actually is. So a defect is a condition where the actual behavior of the application does not match the expected behavior. So for example, if the requirement says user should be able to log in with valid credentials, but the application does not allow login even with a correct username and password, so then that is considered as a defect. Now once the defect is identified, it does not just disappear. It goes through multiple stages, and that entire journey of the defect is nothing but a defect life cycle, or we call it as a bug life cycle. The defect life cycle is a sequence of statuses that a defect goes through from the moment it is identified by the tester until it is fixed, verified and finally closed. Each status clearly defines who is responsible, what action is expected, what happens next. So now let us go through the exact flow, one status at a time, based on the diagram you see. So when a tester finds a defect for the first time, the defect status is set to new. So at this stage, the defect is logged in the defect tracking tool such as Jira or ALM or any other defect tracking tool. Proper details are added such as summary, steps to reproduce, expected result, actual result, screenshots or logs. So let's take an example. Imagine you are testing a login page and you enter valid username and valid password. After that, you clicked on login button, but the application shows an error message and you are not able to log into the system. So in that case, you log a defect and initial status is set to new. So after the defect is logged as new, it is reviewed by the test lead or the development team, and then the status is changes to open. So open means the defect is accepted, it is valid and it needs to be worked on. So once the defect is opened, it is assigned to the developer for fixing. Now the developer starts working on the defect for a fix. So after identifying the root cause and applying the fix, the developer changes the defect status to fix. So this status is updated by developer, that is fixed. So important point to remember here is fixed does not mean the defect is resolved. It is only meaning that developer claims the fix is done. So now the defect goes back to the tester for verification. So once the defect is marked as fixed, the tester performs retesting. So retesting means executing the same steps using the same data to verify whether the defect is actually fixed or not. So if the application now works as expected, that is the defect is resolved, the tester changes the defect status to closed. The closed means issue is fixed, it is verified by the tester in retesting and no further action is required. So now let's talk about a very important real-time scenario. So what if the tester retests the defect but the issue is still present? So in that case, tester reopens the defect. That means the status becomes reopen at this point. So reopens means fix was provided by the developer, but the issue is not resolved correctly. And the defect goes back to the developer again. So in this case, once it is reopened, developer will get that defect again. And this will again follow the same process. Developer will work on the fix, tester will retest. If it resolve the issue, tester will close it, or else if it is failing again, it will be reopened again. So this loop can happen multiple times in the real projects. So again, like if there is one more status, that is the deferred. So if there are time constraint and the defect is having low priority, in such cases, developer may change it to deferred. Again, we will discuss it in few moment later. So sometimes the developer may decide that the defect is not valid. So in such cases, defect is marked as rejected. So if you see, there is one flow here: new, open, fix, and reopen or closed. If it is reopened, then again it will go back to open here, and then again the same process will follow. But now there is one more process. If it is open, so it may go into fix. Developer may provide fix, he may reject, he may defer. So again, based on some reasons, he will update the status. So the common reasons for rejections are: the functionality works as per the requirement, the defect is not reproducible, it is the expected behavior, and it's misunderstood by test engineer, it is related to the environment related issues, it is a duplicate defect, or it is hardware or networking related issues, or it is an enhancement, or it needs some more information. So in such cases, developer may mark it as rejected. So for example, tester reports that the login button is slow, but the requirement does not mention any performance expectation. So developer may reject it. Another important status is deferred. So the deferred means defect is valid, but it will be fixed later, not in the current release. So the reasons could be like a defect is having low priority, there are time constraints, there is a feature freeze. Okay, so for example, there minor UI alignment issue found just before the release. So in such cases, team may decide to defer it. Again, based on the priority, time constraints, and feature freeze. Sometimes a tester may log a defect that already exists. So some other tester has already reported a defect, and the other tester is again reporting the same kind of defect. So in such cases, the defect is marked as duplicate. So again, the statuses you see on the page on this slide can be customizable in your defect tracking tools. So whether you are using Jira or Bugzilla or maybe ALM, you can update this, like these statuses. You can customize it based on your requirement. Okay, so you may see in your application that you have a duplicate status as well. Okay, so if there is a duplicate status, you can simply, your developer can mark it as duplicate, or if it is not there, then he can simply reject it. So again, based on the requirement, definitely they will customize the statuses in their tools. Okay, so let's quickly summarize the flow. So first is new, then open, fix, and then retest. Okay, so in here, after retesting, it can be closed or it can be reopened. If it is reopened, again it will go back to open here. Okay, so when the defect is first reported, it is marked as new. After review, it moves to open when developers start working on it. Once the fix is implemented, the defect status becomes fixed. The tester then retests it, retest the defect to verify the fix. If the issue is resolved, it is closed. Otherwise, it is reopened and sent back for fixing again. Okay, so other possible paths are, at this point, developer may reject it based on the reasons we discussed. He may defer it or mark it as duplicate. Okay, so every status has a owner, a purpose, a real-time meaning. Okay, so in interviews, do not just list the statuses, always explain who changes the status, why it changes, and give some real-time example. That's what interviewers look for. Okay, and that brings us to the end of today's session, defect life cycle. So if this explanation helped you understand defects clearly, make sure to like this video, subscribe to the Quality Analyst YouTube channel, and share it with someone preparing for the testing interviews. Okay, in the upcoming videos, we will cover defect severity priority, writing some effective defect reports, and real-time testing scenarios. So until then, keep learning, keep practicing, And as always, happy testing.